The topic will explain in this video is trigonometric Fourier series representation of the periodic signals. Trigonometric Fourier series, Fourier series representation. Fourier series representation of the periodic signals. Periodic signal means a periodic function x of t is one that repeats every t naught seconds. That is the definition of a periodic function. A periodic function f of x of t is one that repeats every t naught seconds. Therefore, a periodic function x of t satisfies a periodic function x of t satisfies x of t is equal to x of t small t plus n t. According to Fourier theorem, any periodic function of angular frequency omega naught can be expressed as an infinite sum of sine or cosine functions that are integral multiples of omega naught. That is the definition according to Fourier theorem. According to the Fourier theorem, any periodic function of angular frequency omega naught can be expressed as an infinite sum of sine or cosine functions that are integral multiples of omega. That are integral multiples of omega. According to Fourier theorem, any periodic function of angular frequency omega naught radians per second can be expressed as an infinite sum of sine or cosine functions that are integral multiples of omega naught. Sine function is sine n omega naught t. Cosine function is cos n omega naught t. Integrate where n is equal to 1, 2, up to infinity. N is equal to 1 means fundamental frequency, angular frequency omega naught. N is equal to 2, 3, 4 means harmonics of that fundamental angular frequency. According to the Fourier theorem, any periodic function of angular frequency omega naught can be expressed as an infinite sum of sine or cosine functions that are integral multiples of omega naught, where omega naught is the fundamental angular frequency. The unit is radians per second. Therefore, x of t can be expressed as a naught, that is DC component, a1 cos omega naught t plus b, this is a cosine function, b1 sin omega naught t plus a2 cos 2 omega naught t plus b2 sin 2 omega naught t plus a3 cos 3 omega naught t plus B3 sin omega naught t and so on. This is the omega naught is the fundamental frequency, angular frequency. 2 omega naught, 3 omega naught are the 3 omega naught are the harmonics of the fundamental angular frequency. A naught plus A1 cos omega naught t plus B1 sin omega naught t plus A2 cos 2 omega naught t plus B2 sin 2 omega naught t plus A3 cos 3 omega naught t plus B3 sin omega naught t up to. Therefore, x of t can be expressed as A naught plus sigma n is equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. Therefore, a naught plus sigma n is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega naught t. These are the coefficients where omega naught is the omega naught is 2 pi by t naught. 2 pi by t naught is called as angular frequency. Angular frequency. Unit is radians per second. Cos n omega naught t and sin n omega naught t. These are the functions which are involved here. The sinusoid cos the sinusoid sin omega naught t and cos omega naught t is called the nth harmonic of the quotient A naught is the DC component or average value of x naught. The coefficient A naught is the average or DC component, average or DC component of the x naught. The coefficients an and the bn are the Fourier, the constants. The constants, not coefficient, the constants an and bn are the Fourier coefficients. The Fourier series of periodic function x of t is repetitive that resolves x of t into a DC component A naught and AC components comprising an infinite series of harmonics of sinusoids. X of t is a periodic function consists of DC component A naught and the sinusoid components A and B. These are the important constants which are involved in the x of t, A naught, An, and Bn. Determination of constants, quotients, Fourier, determination of Fourier quotients. Next, x, we know that x of t is equal to a naught plus sigma n is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega naught. First, you have to determine a naught DC component of that Fourier series expression. Integrate x of t over interval. The interval is defined as a t naught to t naught plus t naught or 0 to t naught or minus t naught by 2 to. We use any intervals for determination of a naught, a and b. Next one is, this is the equation 1. Integrate that equation 1 by using this interval t naught plus small t naught plus capital T naught. I selected this one, x of t. Integrate this periodic function x of t over the interval t naught plus small t naught plus capital T. Okay, we know that x of t is equal to t naught small t naught plus capital T naught. X of t is equal to a naught plus substitute one equation in that one. N is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega into t. Therefore, integral small t naught to small t naught plus capital T naught a naught dt sigma n is equal to 1 to infinity an is bring out small t naught plus capital T naught cos n omega naught t dt plus sigma n is equal to 1 to infinity bn integral t naught plus t naught sin n omega naught t. Integral over period t naught small t naught plus capital T naught cos n omega naught t dt is 0, and also this integral is also 0. Finally, according to trigonometric fundamentals, these two integrations are equal to 0. A naught is bring out t naught plus t naught small t naught plus capital T naught dt. Therefore, here a naught integral of 1 dt is t naught plus t naught. Substitute these integrals t naught plus t naught minus t naught. Therefore, finally, integration over t naught small t naught plus capital T naught x of t dt is equal to a naught into t naught. Therefore, finally, a naught DC component of the Fourier series expansion for the representation of periodic signals is, that is DC components, 1 by t naught plus t naught x of t. This is the a naught value. Now, determination of a an quotient, an Fourier quotient. Again, take x of t, periodic function is expressed as DC component and two sinusoidal components, cosine terms and sine terms. A naught sigma n is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega naught. Again, this is the equation. Integrate this equation, above equation, with the interval over t naught to small t naught plus capital T naught, and multiply with this one. X of t is multiplied with cos. Initially, x of t is multiplied with cos m omega naught t. A naught sigma n is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega naught t into cos m. Integrate this above equation by using interval small t naught to capital T naught x of t cos m omega naught t dt integral small t naught plus capital T naught a naught sigma n is equal to 1 to infinity an cos n omega naught t sigma n is equal to 1 to infinity bn sin n omega naught t cos m omega naught t. Expand this one. Integral t naught plus t naught a naught cos m omega naught t dt plus sigma n is equal to 1 to infinity an integral t naught plus t naught cos n omega naught t into cos m omega naught t dt. One more term is there. Sigma n is equal to 1 to infinity bn integral t naught plus t naught sin n omega naught t cos m omega naught t. Here m not equal to n, this value is 0. Here, if m is equal to n, this value is not equal to 0. Here, by using trigonometric identities, here sine and cosine terms are there. Integration over time period t naught to t naught plus t naught is 0. Here is also 0. Here same functions are there, cosine functions. If n not equal to m, the value is 0. If n is equal to m, that value is not equal to 0. Suppose n is equal to m. N is equal to m. This function value is not 0. Okay, here t naught small t naught plus capital T naught x of t cos m is replaced with n cos n omega naught t is equal to sigma n is equal to 1 to infinity an t naught plus t naught cos n omega naught t. Here m is replaced with n cos n omega naught t. The remaining terms a naught cos omega naught t over this intervals, integration over these intervals, and the sin n omega naught t cos n omega naught t dt over these intervals t naught plus t naught is 0. Here m is equal to n. This interval is not equal to 0. M not equal to n. This interval is 0. That is equal to n is equal to 1 to infinity. Treated as the quotient is from 1 to infinity. let it be an integral T0 plus T0 cos square n omega naught t cos square theta is equal to 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2, that is equal to an integral T0 plus 2 1 minus cos 2 n omega naught t by 2 into dt. Here an into integral T0 small t0 plus capital T0 1 by 2 dt. The remaining term integral T0 small t0 plus capital T0 cos 2 n omega naught 2 by 2 value 0, need not write here. Therefore, an by 2 integral of dt T0 plus T0 an by 2 here t integral of d1 dt is t, that is equal to an by 2 small t0 plus capital T0 minus t0. That is equal to an t0 by 2. The function is integral T0 small t0 plus capital T0 x of t cos n omega naught t dt. From that expression, a0 is equal to 2 by t0 integral t0 plus t0 small t0 plus capital T0 x of t cos n omega naught t. This is the A. Next, determination of Fourier quotient. Again, consider x of t periodic function. X of t is equal to a0 sigma n is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega. You want to determine this one? Multiply this entire equation with multiply entire equation, multiply above equation with sin m x of t into sin m omega naught t a0 plus sigma n is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega naught t. Here multiply term is sin m. Again, integrate this above equation over that interval t0 to small t0 plus capital T0. T0 small t0 plus capital T0 x of t sin m omega naught t is equal to integrate small t0 this entire expression a0 plus sigma n is equal to 1 to infinity an cos n omega naught t plus sigma n is equal to 1 to infinity bn sin n omega naught t into sine. Here dt is important. Sine m omega t. Dt also here dt is important. Dt. Respect to okay. That is equal to integral small t naught plus capital T naught a naught sine m omega naught t dt plus sigma n is equal to 1 to infinity a n small t naught plus capital T naught cos n omega naught t sin m omega naught t dt plus sigma n is equal to 1 to infinity dn integral small t naught plus capital T naught sin m omega naught t into sin n omega naught t dt. Here this one and this one is equal to 0. Here also this is also 0 when m not equal to n. For m is equal to n, this integration is not 0. For m not equal to n, it is 0. It is 0. For m is equal to n, it is not 0. Okay. Okay. That is equal to m is equal to n integral t naught plus small t naught plus capital T naught x of t sin m is replaced with n omega naught t dt. Here consider this one sigma n is equal to 1 to infinity dn small t naught plus capital T naught sin m is n omega naught t sin n omega naught t sigma n is equal to 1 to infinity bn is treated as bn. Here t naught small t naught plus capital T naught sin square n omega naught t dt. That is equal to bn small t naught plus capital T naught 1 minus sin square theta is 1 minus cos 2 n omega naught t by 2. Here here 1 plus cos 2 n omega naught t by here 1 minus cos 2 omega. Here bn into small t naught plus capital T naught 1 by 2 dt. The remaining term is 0. Integral over t naught small t naught plus capital T naught cos 2 n omega naught t by 2 dt. That value is 0. Here dn by 2 integral of 1 dt is t naught plus t naught to t naught, that is equal to bn by 2 t naught small t naught plus capital T naught minus t naught, that is bn t naught by 2 integral small t naught plus capital T naught x of t sin n omega naught t. From that expression bn is equal to 2 by t naught small t naught plus capital T naught x of t sin n omega naught t. These are the Fourier series expansion quotients. A naught is equal to 1 by t naught integral t naught small t naught plus capital T naught x of t dt, and an is equal to 2 by T naught, small t naught plus capital T naught, x of t cos in omega naught t dt. Dn is equal to 2 by T naught, small t naught plus capital T naught, x of t sin n omega naught t. With this, the derivation is